One that I've had some personal interaction with over the years in Ohio, of linking up the folks in higher education and the supercomputing center with the K-12 community. And it's one of those relationships that perhaps some of you have experienced in your own states, that it can be at times fraught, because the post-secondary community has its own set of relationships, the K-12 community, and sometimes it's difficult to bring them together. This one has been quite a few years in the works, and I want to commend Anne and her colleagues on their tenacity in bringing this to fruition. And I'm going to turn this session over to Anne to talk more about what they're doing with electron microscopes.
Yeah, absolutely. There's the. I forgot I had there was one video embedded.
Sure.
This actually isn't just on remote microscopes, but actually remote instrumentation, which involves telescopes and a spectrometer, a nuclear magnetic resonance, which actually, we are network people. I actually have a teaching degree, but all the science is all very new to us. And I'm Ann Zimmerman, TJ Sandor, and we actually manage all the higher education schools that are on our network, on ORNet. We have probably 85 to 90% of the colleges, universities are on our network. K through 12 uses our backbone, and now the state of Ohio is putting all their agencies on our network. So we are very, very busy. The state tried to build their own network, went out to bid, did some consulting, and then came to us. So we're actually, so it's a good opportunity to get research, education, to collaborate on the network, since we're going to have a lot of resources like the Department of Health and so forth that will be on the network. We have a very robust network, and we are able to do applications like this within Ohio, and it's basically, it's not on commodity internet, just on what we call intra-Ohio bandwidth. So I'm hoping that as you see some of this, we can, reach out to the rest of the United States or even the world and use the internet too. I've been at ORNet 2.5 years, and the K through 12 just got internet too as of July 1. So they hired a consultant who hopefully will come to the spring meeting, and I can introduce her. But so we're looking for applications to, for internet too, to bring to Ohio, and also to spread on internet too.
Before we get started, too, I've got to give Ann some credit here. We worked on the presentation together for the past 2 weeks with Dr. Kalyam, who's actually one of the primary investigators on the project. But Ann Zimmerman has been working with Autism Speaks, and for like the last week, she's been working with her son, both her sons' middle schools, and they had 8,000 people turn out for a walk on Sunday. So she was walking in a walk for autism on Sunday before her flight to come down here. So just
it looks like we're going to raise $500,000. So I'm very excited about that.
All right, cyber-enabled instrumentation is what we've been talking about or introducing. Thanks to Susan for bringing us into it with the Southern Skies Initiative. All it means is cyber-enabled is just a buzzword, meaning you have an instrument that maybe you wouldn't normally have access to, or a very expensive scientific instrument out there that has a computer attached to it. And the computer can be configured to access the internet 2, and software can be installed both on that machine as being a server and client machines virtually around the world to access it. So again, it's just really a buzzword to just say that we have a very expensive piece of equipment out there. It could be anything. Again, it could be like we were talking about telescopes, electron microscopes, the NMR. We'll talk about more with Miami University. Installing software and accessing it remotely.
Okay. Yeah, the reason they want to, we actually went and visited the spectrometer down at Miami University. And obviously these items are extremely expensive, very expensive to maintain. So the idea is, and this would help people collaborate, is that one university or so forth, and usually it's funded obviously, buys a piece of equipment and then they're able to share it, hopefully across the United States, but using internet too, or across the world. And then they'll recoup some of their costs, and then also is much, much cheaper. You don't have duplication of efforts. I don't even know what the one we saw cost, but it was, I imagine.
You know how much the NMR?
More than you raised.
Yeah, right.
I believe that's why we have the 4 million in here, because just that one NMR, and just the cost alone to maintain it, because it has to stay at virtually or almost 0 degrees Kelvin.
So, as I said, it's a return of investment for the instrument labs and then avoids duplication of the equipment. There are a lot of challenges. In fact, coming here last night on the plane, I was reading that if there is a bottleneck when you're using the remote instrumentation of the last mile, it can cause damage to the instrument. So you just have to, and then storage obviously is a huge element. We are actually kind of part of the Ohio Supercomputer Center. So that's where the Supercomputer Center actually services all the higher education schools in Ohio, which is how this project actually got underway. And so we're the network people trying to get it out there. So there is a lot of things to consider. And the other thing I want to say is, as you do these projects, even using the remote instrumentation, you're able to get grants and so forth to help you fund that, pay for that. Just pay the lab for whatever fees they need.
Here's an example from the OSU chemistry lab. This is just a high-powered microscope. And just to give you an idea, the microscope itself is the cyber-enabled instrument. So it just has a port or some kind of serial connection that allows remote control from the attached PC. And PC has the advanced network and multimedia cards. The multimedia is important because it might be processing high resolution video or just graphic. And on the computer you have the live view, so you can do it through a web browser, dual monitors, depending on the piece of equipment itself, depending on the instrument itself. And in this particular example, there's a self-contained webcam. Very much like the little Polycom units, for example, we're using here in this room. So the OSC's cyber-enabled instrumentation program, we use the network in Ohio, and ORNet is the entity that runs the network. So the OSC net is the actual physical infrastructure, and might talk more about that. It's the fiber infrastructure in Ohio. Also, we have high-powered computing to process the data because these instruments are obviously going to be outputting much data. Storage facilities as well at Ohio Supercomputer, and the analytics. You may not be processing them yourselves at your site, but you'd be processing them possibly using one of the supercomputers that we have on location. We've had pilot programs funded by our Ohio Board of Regents. Like it says here, we'll leverage Ohio's investment in scientific instruments, wide area networking, high performance computing, data storage, and to foster academia, industry collaborations involving cyber-enabled instrumentation. So finding applications for high-speed networks is the ultimate goal. Our partners in the initial pilot for the RI there is remote instrumentation. The cyber-enabled came later as kind of a buzzword, but the remote instrumentation program itself, the pilots came from work with Miami University, again with the NMR, the nuclear magnetic resonance spectrometer, Ohio State University and its Electron Microscope, and also the nuclear accelerator that is at Ohio University in Athens, Ohio. And actually, one of our colleagues that's with us, Karen Tomko. She will be working the live demo, or we'll all be working, but the live demo during the meeting. We'll have the times at the end of this presentation.
Tomorrow, Wednesday. Okay, so it's a great application to bring, research, education, the lab, and industry together. We're developing a web portal, OSC, the Ohio Social Computer Centers, to make it, easy to access, and in order to, for the students to either remotely control these instruments over the web. And that is unfortunately still under a pilot stage, and we haven't, gotten it out there, but we are working on that. And we do have it actually used. We're doing a welding application that we developed, OSC developed, for a welding company, where they use a portal and they put in some statistics and they come out with different information for companies that use a welding application. So we're doing all kinds of different things.
The web portal.
The web portal.
The RICE implementation itself is in practice right now.
Yeah, we're developing these acronyms, a remote instrumentation collaboration environment, which is just basically the ability to go in and it's almost like when you call a help desk and you need help with your computer, where they take control of your computer, so the person at the one end goes in and can control the computer on the other end of the instrument on the other end. And that's what we're actually trying to, I don't know if they're going to patent it, but develop it. So you have the remote site, user site, and then you have OSC, where we have the data storage and the analytics and the network and data security, and then the instrument lab site, which we'll show you a picture of.
The picture will come a little bit later. I'll talk more about the RICE software. It's a software-to-software solution right now, and it runs on a Windows operating system. The example will be for Windows operating system, but RICE does work broader than just Windows. There are applications for Linux as well as, there is the VNC client for Macintosh as well. The remote instrumentation control environment is RICE. It is, if any of you, how many here have used VNC or heard of VNC? RICE has been developed from the open source code for that. So it was just like VNC when you started up, except for a menu bar and some additional pop-up features that were built into it. It is network aware, so just like VNC, it will attenuate the amount of bandwidth that you're using. So whether you're connecting to a telescope in the southern hemisphere or connecting to something that is in your state, it'll optimize the network traffic. It'll control the network traffic. And it allows for this is important too, you can manually adjust the video quality on demand as well. So in case, like Ann was saying, you don't want to damage the equipment. So if you need to attenuate the video or the actual data stream or the video stream manually, it can be done from one of the pop-ups that have been built into RICE. It has collaboration built into it. You can voice chat. There's actual just regular text chat, and also control lot passing. This is what's nice, is that the observer can pass control to, the operator can pass control to one of the observers, or an instructor that's leading a class, teaching, being the operator, can pass control on. And it supports multiple display resolutions. Again, all this is for bandwidth usage. So it can run as a windowed application. It can run in full screen. Again, just like VNC, for those of you that use VNC. And it can also run dual screen. This is an example of the RICE software itself. The video is actually, this is actually a video. The changes are so subtle though, you may not see it all. But here, this particular instance is a window example. So you have the RICE running as a window, because you can see the minimize and restore control blocks at the top. And what you're seeing here is a program menu. So again, this is the RICE application. What's inside here is the actual remote device. So we're looking at I believe this is from a microscope, one of the high-powered microscopes. I don't know exactly what the video was from, but this is the remote instrument right here. So you're actually controlling or looking at what's happening on the instrument at your remote location, or at the remote location. And this is a chat box. This shows you who's connected. Since it's multi-user, you might have the instructor and then several students connected. That window will show you who's connected. This is where you can manually control the quality of the connection, should you need to, again, this is client side. So if it's slow refreshing or you're losing connection, you can adjust it. And a voice chat, obviously you can't see it because it would be something that you hear. That's also built in.
The one thing that's really nice is they can actually use the right software. Like, say you put this in a high school, which they've actually done. They can use the software to teach the students how to use the remote instrument before they actually do it. So it can be used on different levels. It can pass control back and forth, as TJ said. The one thing Dr. Kennedy, I'll talk a little bit about. Dr. Kennedy at Miami University is the one using the spectrometer, the nuclear magnetic resonance. And he is very interested in reaching the underprivileged students. And when we went down there, we actually saw the device and saw it work. And that's what we're demoing tomorrow. But he said he did it at a local high school, but he would be more than willing to do a demo at a high school or, work with somebody to get a program together. I mean, he wants to really drive STEM and let students know that, it's not just pure science. I mean, you've got you've got the mathematical, the statistical. There's different facets that students can get involved in, and it's just not a science environment.
So they're cute to get on.
So, and I did not, anyone that's interested in getting Dr. Kennedy's information, I just didn't want him to get bombarded. It's kind of hard to get a hold of, but if you're sincerely interested, we'll be happy to put you in touch with him because he's very sincere about this. And he'd like to go down to the middle school.
What is the last mile?
We're trying to find out exactly what.
For which part? Just the Rice software itself.
Any instrument.
Well, in
It's
order
like
to
3
actually,
megs. It's not a lot.
It is actually not a lot. The instrument itself is going to have, well, it's all going to be using broadband. So it's going to be, I would not do it on anything less than a 10 meg connection.
Okay, that's what I want.
Yeah, I would not either.
Okay.
You could go down on a smaller segment. It would not be for like a T1. Exactly. The Rice software itself on the client side, you could use up to about a meg of bandwidth. When you add video, consider your video stream as well. If it's high density, you're going to have a high definition video, then of course you're going to have 2 or 4 meg. If you're also, because you can actually run the video application separate or along with the Rice itself. But it's definitely a broadband application. The application over internet too is just a guide.
One quick thing, the FCC defines broadband as 768. So
Right,
using
yeah.
that commercial just doesn't match.
Yeah.
And that's the redefined one.
Huh?
That's the recently redefined one.
That's the redefined.
Yeah, otherwise it was
It's the one we're working on tomorrow.
And then Ian wanted to talk about
Yeah, this is we actually went there, this is a spectrometer, and they actually put like a little vial on the top of, you usually use urine or blood samples, but I mean, it's huge. You can see how you go up the stairs and then the computers are down there, and those are what the computers you actually access, like down over here. The nice thing is too that the students can be actually doing research. I mean, one of the things they're using this, and I learned, like, the spectrometer actually measures the vibration of molecules. That's the graphs that you'll see tomorrow if you come to our demo. But they're using it now extensively with a possible detection for pancreatic cancer, because I've learned this as well, that pancreatic cancer obviously is very deadly, but it's because it's not detected in stage 1. Less than 3% of cases are detected in stage 1. We always get it later. So they're using this type of thing to try to get a detection for the stage 1 of pancreatic cancer. And you know, for students, that's huge to actually be working on something that's, you know, that means, you know, a lot. I mean, it means saving lives. So again, the whole project was subsidized by the Ohio Board of Regents under a professor, and actually Dr. Prasad Kalyan was supposed to be here, and he's doing another presentation in Canada, which is why he's not here. They've collaborated doing the spectrometer with Bowling Green, Ohio University, Muskingum College in Ohio, and the Talawanda High School, and he's working with the school district in Cincinnati. But again, we can do that over our network because we have such a robust network in Ohio. Okay. So yeah, we're fine. So anyway, we'd like to get it out and have someone else try to pilot it elsewhere.
Especially
How long
outside.
does it take for the teachers to learn how to come up to speed on using the tool in their class?
No,
Well, the teacher would work with professor at a university level on the instrument. So if you have a teacher that's a chemistry teacher in the high school, she's going to be the direct liaison with one of the professors or with the lab technician running the instrument at a university site, for example. They would work together and work in conjunction when the actual presentation is being done, when the actual experiment is being done. The data can then be processed either there on site, because most of these machines, most of the computers that are attached to the instruments have some initial data analysis built into them. For example, TopShit on the NMR, this program that they use to control it. It does some graphs initially right there. As soon as you put the sample in and run it, you're going to see the spectrograph.
So do they have the samples already available, or are the students collecting samples?
Depending on what they want to do. For example, they did the
Coke, Diet Coke. It's
different sodas.
various Cokes.
In this case, yes, it was Coke, Diet Coke, caffeine-free Coke,
Coke Zero.
and Coke Zero in urine. And the sample was taken from the classroom and sent to Dr. Kennedy. The lab processed it and put it into the NMR, and they compared the results. The difference is, you know, the different levels of different molecules, how Splenda will show up in your urine. So it
Did
is
they do it
actually
through
very
blood and urine samples, or did they do the?
No, they did.
I mean, you said blood and urine earlier, but I was thinking they sent coke in.
Cancer
Not.
studies to
Oh.
to check for cancer.
Yeah, they did urine samples.
Let's quickly go over the demonstration times. I know we're almost out of time. So tomorrow, 10 a.m. to 10:30, 2:30 to 3, 4 to 4:30, and Wednesday, 10 a.m. to 10:30. I believe all this is in the pocket guide. Karen, which one's the actual live demo is going to be?
We're going to work with Miami at the break times, so the PhD student cooperates so that she can be available. So we're going to connect to the spectrometers during the breaks, and beside this plan, we have a short video of the session.
And actually, to answer the one question that was asked, it'll be a great example for how an operator, we're going to be interacting with the operator. So, for example, Karen could be a teacher working with an operator in Oxford, Ohio, as we, the class, are viewing the results.
We'll come by. It's during break time. We can go snack.
Doesn't time on these incredibly expensive machines cost a lot of money?
Pardon me? Time?
Doesn't yeah, I mean, they cost.
There is a
Fee, but I don't know that it's, you know, well, they haven't actually even, you know, developed a cost structure yet. So, but I think the idea is to make it, you know, they want to get it out there, so they'll do, and they've already been funded up front. I mean, obviously they have time, so they're.
The state of Ohio. But for applications outside the state, we're still working on cost structure of pricing model.
What are your thoughts on scalability for some of these cyber-enabled infrastructure projects? Because as we move from a model where it seems like in a lot of cases it's been kind of here and there to situations where we have whole states that are sec-P and trying to build programs where, you know, maybe every 4th grade or 10th grade student or whatever has access to these sorts of things. How do we look at models that can actually scale to those sorts of large-scale uses?
One of the examples we had been looking at was, at least Prasad, just got was talking about was, has anybody heard of Bugscope?
Of what?
Bugscope. I believe it's out of the National Supercomputer Center, or it's the University of Illinois. It's just a high-powered microscope that elementary and middle school students use to look at insects. And they have a whole scheduling system, a price structure. You know, I don't know if it's just bugscope.edu or .net out there, but do a Google for Bugscope. And that's one of the models we were actually talking with Dr. Kennedy about. You know, could we use this kind of model where samples are sent in, and in the case of the NMR, some of the samples, timing is an issue, but you know, we kind of structure it like that. It was an idea that we tossed around with him. Right now, everything is done case by case basis.
As I say, I encourage you to, if anybody's really interested, and maybe over time, you know, be successful in developing a model based on your needs, because we're just in the development stage here.
Thank you very much.